Hey everyone, in this lesson we are going to continue to study IP routing. So on the previous lesson we saw that routing was the manner in which datagrams walk over the networks. We also introduced the routing table, and given this network structure that we saw the routing table of PC1 for instance, and also the routing table of the router R1, right? This is what we saw on the previous lesson. So now, for instance, given the routing table of PC1, how can PC1 know if a destination is on the same network where PC1 is? Well, the way that this is done is we want to go imagine to this destination, right? The destination that we have here inside the PC1 routing table, right? 10.0.2.0. This is a network destination, therefore the mask is 24 bits, right? And now what we do here, PC1 is going to do a AND operation. Remember the bitwise AND? Okay, the bitwise AND operation is a operation that we do bit by bit. That's why it is called bitwise. And the logic gate AND is a logical operation that returns 1, okay, even only if both of them are 1. This is because this is going to return true, which is represented by the number 1, even only if both of these conditions are true, basically if they are satisfied. So 0 and 0 return 0, 0, 1, 0, 1, 0, 0, and finally 1, 1, we have the result 1. Right? This is the AND operation. So if we have this mask, okay, of this network in here, and we want to go to this destination, well, we only need here to do the bitwise operation between the mask, right, and the destination. So we can see that since we have all ones in here because this is a decimal value, right, 255, of course, the result is going to be 1, even only if what we have above is 1. So to explain this and to fully understand this, let's boot and view this with an example of the first case. So we have this network 10.0.2.20, this destination, and we have this mask. So what if we do the AND operation between 10 and 255? Well, first thing, we represent these decimal values with binary, right? We represent them in binary. Now we do the AND operation, right? The AND operation is the operation that we are doing in here. So 0 with 1, what is? Well, 0 with 1 gives us 0. 1 with 1, 1. 0 with 1, 0. 1 with 1, 1. And all of the remaining are zeros because we have here that the above is 0. So what do we have at the result? Well, the result is also 10. Right? So that's why if we have a mask of 255, so whenever a mask is all of the elements 1, the result of the AND is always the same as the original value. So this is the mechanism that is done to check if this is the same network or different from the network where PC1 is. And we can see here, since the result is this one, 10.0.2.0, right? Keep in mind that the last AND operation between 0 and 20 in this mask is going to be 0, because we have here that the mask is 0. So given this here, this network, okay, we can see that this network is different from the original one. And in fact, what we are going initially, okay, this destination, we can see that is not a network. This destination is a host, in fact, right? This destination is this host that we have here, PC4. Right? So we want to see if this host is connected to the same network, if this destination, if this PC4 is connected to the same network as PC1. And this is the procedure, right? We do the bitwise operation of the AND between this and the mask, okay, of the PC1. This is the mask of PC1. And then we check if this resulting value is the same as the network of PC1. Of course, this is not. The network is 10.0.2.0. This is different from the network of PC1. So therefore, this destination, this host, this is a host, is in another network. Now, also very important, how is this order of consulting is done? Well, always we here follow the principle of the longest match lookup. This means that PC1, or whenever PC we have, or also routers, will consult its routing table starting with the entry with the highest number of 1 in the mask. So we have the same example, this destination host, right? Of course, what we are going to start with is with the largest mast. So the largest mast is here the greatest number of 1s, which is this one. So now if we do the AND operation between those two, we can see that the result is the same as the above, because we have all of them to be 1, okay, in binary. So this destination 10.0.220 is different from the network, and there is no entry in the destination column with this value. We can see in the PC1 there is no destination with this value. Following this principle, the second one that we are going to check, okay, is the second largest mask. So the first one was with all ones, now the second largest is where we have all ones in the first or in the 3 first decimal places and 0 at the end, right? So we do the AND operation, now we have this result, and this is different from its network. However, the third entry in the destination matches. We can see that this value, this result of the AND operation, is inside the table. It's inside the routing table of PC1, right? So the third entry of PC1 here in the routing table is the destination that matches with this destination win here. So in that case, if the destination matches, the datagram is passed to the router. PC1 has completed its task, okay? And the table says in this case that we need to send to this, needs to be sent to this interface E0 by 10.0.0.1, right? From PC1, if I want to reach this network, I need to pass by this interface in here. What about the routing R1? Well, R1 will do the same, okay? It will consult its table and check if the destination is on one of its networks. So first of all, we see here this destination. It is going to do the AND. Keep in mind that we are in the same case, this destination. So we are already done with PC1. Now we pass to R1. We have the same destination. We do the mask of the networks. We can see that these are 1. If we do the AND operation, this here, this result matches the third entry in the routing table, right? So we can see here, this is the interface. So the table says to send by the interface E2 to the destination that is in the network, right? So this is precisely what we see here, because if we send by E2, okay, with this interface E2, we reach this network, which is basically the network where this host is, the destination that we want to send to, right? So very important, when an entry matches the table says the interface that we need to send by. So in this case, for R1, the interface is C2. We can reach this network, and so therefore we reach also the destination host. Now, this principle of longest match lookup is important. Okay, and let's see an example of this. So we here now see another network structure. We see here we have the PC1, PC2, PC3, PC4, PC5. We have also 3 networks, and we have the routers, right? Now here we see the PC1 routing table, okay? So for instance, if I want to go to this network 4200, of course I don't need to pass by any other router because we are directly connected to this network. So the gateway is 0000. Here the acquisition field is omitted. We are not going to now look at the acquisition field. Let's only look here at the fields of destination, mask, gateway, and interface, right? If I want to go to this destination, this is the mask, the gateway is 0000 because it is directly connected. If I want to go to this network 5200, which is this one, right, then I need to pass by this router or 2, and the gateway is this one. Remember, the interface or the IP address where we reach, okay, we arrive to the router. So if I am the internet, if I come from a 0000, or in this case, I want to go to the internet from PC1, right, from a default network. Also, okay, it is very important to here, know that we have the consideration we need to pass by router R1, right? And finally, on the destination, if I want to go to 52020, right, that we have here this mask, which is going to be a host, because we have all of them to be considered. This is this host in here, 52020, this is the PC4. I will go and will pass by this gateway here on the router R3. Keep in mind that I can also arrive through R2 and also R1. So why do we choose? Why do we choose this gateway, right? 4203. Well, let's see. This is the principle of the longest match lookup. So let's begin. First of all, if I want to send datagrams to PC2, this is very easy because this PC2, this host, this computer belongs to the same network where I belong. We have a direct route. right, by this first entry. Now, what about if I want to send datagrams and information to PC3? Well, this PC3 is now in another network, and now when we do the AND operation, the bitwise AND between this host and the mask, which is here 24 bits, right? So we have 3 decimal places to be 255, which is the same as 8 ones in a row in binary. If we sum all of the ones, we have 24 ones. We see that the result is this one, right? 5200. This is different from our network, therefore we conclude that this host is in another network, right? PC3 belongs to another network. Okay, so now let's try to go to this destination with this mask in here. So we are not going to go through this route, because if we do the bitwise AND, we can see that this host is different from this host, so we are not going to go through this route at the end. So now, after this is very important, after checking if it belongs to the same network, the next step, as we can see, is to go, okay, and compare with the mask that we have, which is the biggest one, the largest mask. So first thing, okay, we check if this destination belongs to another network. So we can see that first of all we compare this with our network, right, and PC3 belongs to another network. The following step in the principle of the longest match lookup is to check, okay, with the biggest mask. So the biggest mask is the last entry. So we already checked that it doesn't belong to the network, to our network. So now we check with the biggest, with the largest mask. That's why it is called the longest match lookup. We check, we can see that this host is different from this host. We are not going to go through this route. We continue now with this mask in here, right? So we go to the second entry. We go this same destination with this mask. We get 5200. So this 5200 is the same network where this host is, right? 52010 belongs to this network. So it goes through this router 5202. That's why in here we arrive to this router R2, following the longest match lookup. So let's continue now with another destination and following this same principle, okay? So this was the destination before, 52010, okay? And now let's see 52020, right? So now we check with the largest mask again, because we know that it doesn't belong to a network. We check with the largest mask. So now this largest mask is going to be this one of the last entry, 32 bits. So all of the bits are in 1. This means that we have 4 decimal values to be 255. So we do the AND operation. Of course, since we have an AND where all of the values are 1, the result is going to be the same as the original IP address. So we get this. This is precisely the host PC4. And this result that we get is precisely the same as the last entry, right? So our destination is the same as the last entry. Therefore, okay, if this is the same, PC4 belongs to another network, and also it is going to go through this gateway. So that is why if I want to go to PC4, I will not go through the router R2. I will go to the router R3 in this case, with the router R3. So the reason for this is because I have in my routing table precisely PC4, okay? And following PC4, we can see that we have this gateway, 4203. That is why, following the longest match principle, we need to go through the router R3 and not through the router R1 or through the router R2. Okay, this is how the routing tables are established, and also consider the paths to go to the PCs following this principle. Okay, the longest match principle. Very well. Now, what about the last case? Well, consider now that we have this destination, the destination 62030, right? So, of course, if you try to go to this destination and check if we have the same network, this is going to be false. We are in this network. And moreover, if you use all of the masks, basically the mask 32, so we do the AND operation with 62030 and with the mask where all of the values are 255, the result of this is going to be the same as this IP address, 62030. However, this IP address, this destination, does not appear inside the routing table. So we go now to the next one, right? The next mask, which is 24. So we get only the three first decimal places to be 255 and the last decimal place to be 0. In that case, what is going to happen again is that we will have at the end 6200, and this is also routing in fact a destination that is not inside the routing table. So we are going to discard again. And what is the last mask to check? The last mask is 0. That we have 0. So we have 4 decimal places with 0. This is the last option, and this is what we perform at the end, as we can see. So if we do now the bitwise AND operation between this IP address and this one, 0000, of course the result is going to be 0000, and this result we have inside the routing table. We have it inside with this gateway. That's why here, if I want to go to this network, I will pass by the router R1, which is this gateway 4201. So very important, this is the longest match principle, right? Okay, with this we end this lesson on IP routing and the longest match principle. We will solve problems about this in the section of solve problems, don't worry. And on the following lesson we will begin to study the ARP protocol.